First of all, thanks so much for coming. So numerous. We're very excited to be here in Rooted X. When we saw this X, we thought that perhaps Natividad was coming to give a talk, but anyway, it turns out they don't seem to have come. So we're going to talk about Rootkit busters, which is basically about chasing rootkits in Linux and Unix environments. So, as introduction, I used to be editor of the blog Security by Default. I don't know if you know it or if you follow it, although I haven't been updating it for the last 2-3 years. I've developed tools such as Unhide, anti-ransom, radiography, and you can follow me in Twitter in Jesus. And right now, I work with Garante. We work on digital certification of content. My name is David Reguera. I've been for over 10 years working in this sector, but as a hobby, perhaps earlier on since I was a kid. And my experience is with malware from when not many people were interested by it, particularly things to do connected with kernel. It's one of my passions, and I've programmed a few things in these areas, in the x64, DGB, Rootkit and Hooker, DB Child. And this is my tutor, in case you want to follow me. And whoever is writing to my mobile phone, please stop. So that's all. Let's move on to the presentation. Rootkit, we have to say, is not exactly the end, but it's when you use a rootkit, it's not an end in and of itself. It's just a tool, a service tool, something that provides service to an attacker to hide things. We all know that the mining and Trojan tools have become very trendy, and to make harder the detection to a forensics analyst and to an antivirus process or whatever, people use a rootkit. Rootkits allow you to hide from a file, a connection, a process, many things. These are tools that are constantly evolving. The ones that used to be used 10 years ago are not the same as the ones that are being used now, and it's the mouse and cat game. You apply new techniques, and they have new techniques for the new techniques, and we move forward that way. And one of the most important things of a rootkit is that it is necessary to preserve the privileges. We're going to see a rootkit demo for those who've never seen one and they're only familiar with the concept. So the goal with this demo is to see how an attacker would see it and what would happen in the victim machine.
Aquí arriba a la izquierda voy a poner la máquina.
So here to the left, I'm going to show the victim machine. And now we're going to set up the attacker machine. You should have had that in place. So here to the right, can you read it or should I expand it a bit? Bigger, bigger.
Tampoco puedo mucho más, pero bueno, así. Vale, perfecto. Bueno, pues aquí en la máquina atacante.
So this in the attacker's machine, we can directly connect with the machine, which has a backdoor. so that when the attacker connects in a particular way to a service, that might be the Apache or any or an internet server, then the attacker connects. And here, and this is the connection. This is the terminal you're seeing here. So the stolen router is in red and everything's hidden. So all processes that are launched from this terminal, files created, connections, all of that done from here, the legitimate rootkit of the machine cannot detect it. So that's the goal of this rootkit. So we're going to do a test. We're going to leave here running a top process. And this is the root from the machine, and they're thinking, the machine is taking longer and longer, and they do a grep top, and as you see, they are not seeing what's happening, what processes are being run in this machine. If we want to look at the connections, we see 130, which is the victim machine, but the attacking machine, which is 131, we see no connections. So in this way, the attacker can introduce any type of malicious process. As my good friend Albert Reguera would say, the malicious process. This is a joke about the Catalan situation. So this is just a small demonstration where you can see what the attacker sees, what the victim sees. So as you can see, it's very simple. There are many tools available that somebody without too much knowledge can grab, adapt, and install in a machine, in a TV. GitHub is full of those, okay? There's plenty of stuff. Now we're going to talk about trends regarding rootkits in recent years. When we talk about trends, it doesn't mean that that other things were not being used in that year, but this is in very general terms. If we go back to year 2000, rootkits already existed, and they tended to replace system commands. For instance, in Linux, I have a number of commands, and what I do is replace them so that they hide things. And here they were great engineering works. For instance, like creating a shell screen, a shell script that actually called the right one, but with a grep. So it's very much worthwhile for a consulting company charging 100 euros per hour. You know that Linux is open source, and it was so cheap that sometimes they would get the code source code, they turned it into a Trojan, and they installed it. So sometimes the administrator, whose PS had a number of flags that were not in the Slackware flags, and then it wasn't working. And then they tell me that flag doesn't exist. It was very early in time when people were doing what they could. In 2005, it became trendy to tackle the kernel. The Linux kernel is very good, but it wasn't designed with convincing security features. And that allowed, among other things, for the memory representation of the kernel, which was on the third line, was pretty much editable. So there was a rootkit called Rootkit that patched the memory of the kernel. So it was great for the attacker because it was quite difficult to detect. When it came to accessing the sysvol table, which is where the calls of the systems are mapped, when it's at the end, and those were public, so it was very easy to find the locations and change. So these were times when everybody was doing rootkits for kernel, and thanks to that, many improvements were made. For instance, the syscall table is not so easy to find. You need to do many more things. You cannot write and read in the devcam m. So sometimes when you go against the kernel, it's quite delicate. So if the machine, the administrator had compiled the root, the kernel, they had parameterizers, and it crashed because it wasn't the standard kernel.
So, if we can see the current trend is hooking. So the idea is to inject a library or to put a library with features that have been altered so that when the binary is going to use, a library will be uploaded below with a function, with the functionality that is the functionality you're interested in. So you can use, you hide X user, or you can hide other files that belong to other people. So the important thing for this rootkit, as David would mention, that exists in great numbers. So it's very difficult. It's very easy to come up with one for a different environment. So ld.so is also preload. So they are easily to be detected, because if you compile a tool with a GCC on static mode, you will not upload the library and everything is in this mode. Yeah, for example, very often when this became popular, there were rootkits that detected static compiling, and they alter for you to have, instead of ld.so.preload, you have a different file, because the binary was modified, or the part of code reading that file, and they replaced this by another one of the system. So that was the idea behind all this. We are going to enhance all that for us to prevent this to be detected as easily as it is now. Another trend is to inject on the fly, meaning I have a process, SSLH or MDIN or something else, complying with the verification standards of the system. So it's an original packet with a digital signature, and this binary is patched in memory with another feature, for example, a backdoor or a port to be connected, etc. So this is a kind of Trojanization, which is a little bit complicated, because for experts, it is difficult to determine whether or not a process was corrupted in order to be altered with the new functions. And on Linux, it's based on Petrace, which is a functionality available on Linux. So this is how things function now. So now we're going to be talking about unhide tool. I don't know if you've used unhide or not. Please raise your hand if you've used it. But come on. So it should be like a right-wing meeting. So you should raise your hand. So it is packed in a great number of distribution centers: Red Hat, FreeBSD, Ubuntu, or Debian. So you can find it as a bundle, as a packet, as a bundle. And in the README, we advise to compile this statically. Nobody does this. One of the things is that the ideal situation will be to be able to compile in a static machine and then use it. Because if you're using a rootkit, static compiling could be detected, and we have to bear this in mind. And then unhide. So why did you want to create this tool? Well, when I started working with compromised environment at the beginning of my career, by 2002, I saw there were no tools. All the forensic processes based on extracting hardware, so using corners, toolkit, etc., but the like mode had not been exploited, or we didn't have reliable tools to verify the binary MD5, etc., could be used. So we create hype, cross-view based, and then when somebody created similar tools, this was called cross-view. So what it means in plain language is that we are able to compare different things because you have resources to ask the process, what are you, being PS, what do you see? Or you can do something else. You can speak to the kernel directly to compare. So if you know a process is in execution, it should be done from different perspective. And so if you can only see one point, there is a hiding of the other points. So this is a little bit the timeline of unhide. The prototype was created in 2002 in Perl. That was Python at the time. Python was not used. People said, this Python is the future. But then people said, no, but instead of Python, use Perl. So we used get priority for verification. Look for on PS and then get priority to see the spread in the system to see whether or not alterations were done, and then stat. So this is how unhide was created, the unhide that was made public in 2013. Okay, so we are on at the correct slide. So the main techniques for unhide, even if there are more, but we cannot go into all the details. So the idea is we compare PS against proc, PS against syscall, PS against brute force, and then compare this with the bind. So the first one, proc. If you don't know, on Linux, all the processes are mapped on a specific process called proc with PID and a series of data, commands, and the libraries that have been uploaded, etc. So the technique is very simple. If you see via PS a process like PS ID 3222 and then /proc/322, so the two things are the same. But on PS, I can't find a process, but there is an entry in the directory, something is happening, something has been hidden. So with this technique, if hidden processes exist, comparing proc and PS. So instead of conducting a stat for a directory, I use other functions, chdir to execute a directory. So if we open chdir, but there's no proc, there's a problem. So if we use the syscall technique, same thing happens. With PS, I have to see certain process. When I use the system call, which is a fixture kernel offers for certain things, the same thing should be done. So if I use get priority to see what the process is priority, so ID 322, but I don't see it on PS, so the problem arises. So these are the syscalls I'm using. If you're interested in that, you can Google them to know more about each process. So the last technique, which is the most effective, actually, the malware creators talk about this on fora, and they say, well, that is very difficult to skip. And ABC journal talked about brute force, fuerza bruta in Spanish. Brute force. Things are always like that on service. So we have a process, the highest process ID. How many process ID will be delivered by kernel? From 1 to 32,768. So the first were preserved, but this is no longer applicable. So I do fork at a maximum number, and then I will take note for each fork the process ID, and some of them will not be offered because they are being used. It's like bingo, like in homes for the elderly, right? So the process ID gave me 80. So the 91 wasn't provided, so you should use /bin/ps, and this is very difficult to skip actually. I also have to say that we use fort, but we also use pthreads. These are the two ways to initiate processes in unhide. So we have the same technique to know if ports are being used. So if you ask, show me what are the open port, they should be all visible. If they are not visible, netstat. If I want, and compare against bind or bind, bind. So all the ports should be reflected. If not, the port is being used by something I'm not seeing. We also do this for TCP and TVP, and UDP, I'm sorry. Also, I have to say that people made generous efforts to bypass unhide, and one of the things that was done is using command line, and if the process it is called unhide, well, I don't do evil. So someone in a code called unhide gayprox. So the creator of this malware was a homophobic person probably, but I have to say that he said, I think he wanted to change the name. He was not feeling well because he gave the malware this name, gayprox. We're going to show some demos for you to see what happens when someone is using anti-unhide, which is the basic. We're going to show the basic one that is found most frequently, and then another demo with something more complicated, and then a demo with nothing at all, where we can skip this application. So let's see a normal system with a rootkit without an anti-unhide like this one. So let's see how detection happens. Okay, is this one? Okay, so we go back to the victim machine. Here we are. We are the root, and we believe something bad is happening or strange things happen. The system runs slow, so we download unhide, and let's see what happens. Unhide Linux. And the first thing is we're going to enter as attacker to launch a process.
Vale, ya estamos. Dejamos un top.
Okay, so we have this as attacker that is running. So we launch unhide with the sys parameter. Unless someone wants us to elaborate on something, as you can see, boom, there is something that has been detected because it is hidden. So comparing against different sources. Oh, there's a bash, something is going on, which is very strange. So we have a directory here with an ls/lib, and if I try to write something, I'm going to see that nothing happens. There's nothing actually. We have the directory, and the attacker has many things. Let's use another parameter, the brute force. Actually, that launches many processes. It's like a bingo game. So bash was detected. The directory, something strange. P trade is the same thing, same result. So in the end, what you can get, even if you have more parameters, for example, a croc, with these simple things, sys, brute, and proc, the results are the same. We know what hidden process is happening, and things are not going well. So this is with a machine that doesn't have an anti-rootkit, anti-hide system. It is a rootkit that works well, but it doesn't take into consideration this kind of things. So let's see the same demo with a rootkit, with a technology based on the name of the process. I know I'm presenting something of Linux with Windows. Oh, because you didn't see your keyboard. The thing is, we have the same rootkit and the same situation, but the difference is that we are detected. So we have an unhide process, so the rootkit automatically will provide the information to it, because the unhide is seeing the hidden process. Because it was not hidden, it doesn't detect it. So attacker, same thing, attack will launch the attack. So the attack is running. So I will launch now. Unhide. With brute, for example. And like I said, nothing happens because unhide is considering everything. If someone is using btrace, or if you run a strace, you will have everything. Same thing with proc. So let's try sys. Same thing, no result is given. Same thing with proc. No result. Show up. It's a little bit ridiculous, because if I change unhide Linux and I called it hello, how are you, and then execute, and then I write sys, and you say, what the heck? What has it done? It's absurd. But if you don't want to work one day, you can do this. This is something smart, as we call it, actually. So as you can see, this is ridiculous. So we advise you to use static with a safe machine and use any name. And then with these recommendations, you will find everything. And I've downloaded a great number of rootkits with the unhide, and I was wondering, but what do people do? So this is what we wanted to show you. A demo with rootkit, with unhide. So that was unhide 2013. So I said to myself, I don't know what else I can do. And I said, I'm going to call the smarter person I know, but he was busy. So David was free, so I called him. And this is when our love story began, like the Titanic story. And I'm the girl, actually. Yeah, because you have beautiful eyes, so it's better for you to be the girl. So David incorporated improvements in the new unhide. Yep, the thing is, I had anti-rootkits boxes that were all around, so we started working, and then I decided, oh, let's integrate this into something that is well done. So I said, hey, Yago, let's incorporate this. I created Rootkit to see what people can do with that. So the first thing we did is to change the name. So the ideal situation would be if a PT gave and if you want to get the bundle, that would be good, because the executable will start working like that, and people will never know what is happening. So what we did is to add a parameter, unhide Linux, unhide deposit, or other unhide systems. You change the name. You send it to a temporary directory with a random name for it to copy itself, and then you say launch this command. So you launch this random long name you have created, and there you go. So this is one of the things we incorporated. Another thing we incorporated is brute force for the group of users having this file or process. To explain you this, I have to explain you something else before. All the processes on Unix and files have a single number. So many Root creators, because they are lazy or because this is the smartest thing to do, take this group and they generate a number, a magical number they create. For example, 8,721. All the files on the system having 8,721 number are not listed, and the processes running with this will not be listed. So you intercept the calls to the system, and when you see the number, things will be hidden. So therefore, they don't exist. Easy to do with not many failures. So what we're going to do is we're going to brute force them. So again, we were bingo. We're playing bingo. So why, if I create a file and if I put this number, things disappear? Same thing for processes. If I launch processes and I change ID and then it disappears, it's because something is hiding it. Another thing I wanted to comment, but there are people that are more advanced and they don't use this basic thing to hide files, but they use a long name with letters and numbers. So everything having this long list of letters and numbers are not listed. So we cannot use brute force because this long change make this not possible. So how can I hide the process if it is a program that has been hidden? But when I launch this on /proc, on /proc, so we will not have the extended rootkit. So thank you very much, but we will discover what you did. So I brute force files and processes. It's very simple. I get a file and I put group 0. I list it. I can see it. Yes, no. Following 1, 2, 3, 4, and up until 32 bytes or bits. Force brute. So I create a process and I put ID number 1, 2, 3, 4. List. If I can't, is because something is hiding it. Because with /pro, they cannot do that. So some people get an environment variable to try to trace it down, but this is what we did. So what kind of brute force can we implement? As I did this, I used Rootkit I found there. So it's very simple, because so what happens if I'm an attacker and I want to put a web server? Some processes change the user group when they are being executed because they have the setup somewhere else. So you have the process with the magic number to avoid detection, but when it is launched, because it is programmed, another thing happens, so it discovers itself, and the root of the machine will be able to see the service. So I said to myself, that's it. It's very easy. I will launch a process, I said to myself, and I make the process to occupy all the spaces I have. So if it stuck at one point, it is because someone is trying to force me. Because the Rootkit code does as follow. If I am a hidden process and I want to change to a group of users that are going to see me, I can do that. Because when I can no longer change, is because I'm being retained. This is the easiest and faster way. I can do this very easy. Same thing is regroup all users in a process and do read_dir/proc, similar to what a PS would do. But this is slow. Yago tested this on an old machine, and it took him 1 week to see the 2 billion possibilities that existed. So we started with PS at the beginning, so imagine it was not viable, and unless you have a great machine to do that. And then we installed Segit with start/proc / the process being run at the time. So, and if this disappears, there you go. So I don't know if this took us 8-9 hours. Maybe you seem it's long, but you have been running this for 8 hours, and there you see 4 billion possibilities. And Segit jail took 4 hours. I think it's slow, but you have to do that more than 4 billion times, so it's very difficult. Something I didn't see that, and I wonder why nobody did this before. And the other thing I had was a very simple idea. We are in a user space, and when you call an API of a high level for a directory, it will call another one that is less abstract, more concrete. So this is a very simple process. So I call the high-level API, Reguera, all the processes with /proc and then kernel, and I call the ensembler with kernel, and I say, yeah, in 5 minutes I'll have everything. So I said, this is fast, and I detected all user spaces. So I don't call the getDens of Linux. So I get the interruption, I see on kernel what the interruption is, and I call the unifier system. So the problem is that I have to see for each Unix what each system and how it was called, what the enabler is. So get read plus smartdir/proc. Everything is easier to correlate. Some of the problems we had with that was that, oh my God, I've been working with that and it is blocked, and without Rootkit it didn't block. So what is the problem? I said to myself. I realized that many Rootkit code is badly done. The programmer does whatever he wants, and because you don't call many times because a PS does it and then you close it and that's it. But I'm doing QA or fuse, so the process starts and nothing happens, which is okay, because instead of waiting for 2 weeks, in only 2 minutes I make the process. I crash the process in 2 minutes. So when you do that easily, is because the process is not going to be blocked. So this is what it does. The Segit jail was the faster process. But when this kind of tools will give you strange mistake, it is because the machine will have a rootkit. Because the thing is that the machine was blocked with this rootkit. So whenever you see a failure, it is not because we made a mistake, but it is because the rootkit is not good. So let me show you a demo of an API, high level, using brute force. So in order not to be here for a week, what we are going to do is to use a CD that is closed. So we have the attacker, and we're going to launch it for it to detect this, what is running.
So we have what we've seen earlier on, where automatically it goes directly to dash CMP, but if you want it in a directory with a random name, you can do that. So you can do brute force with Reguera, and this is going to be fun, because I do this, and it's very close. And it says the detected gate is this one, 4447. So what's fun about this is that if I hadn't done this for you to see the demo, in 2 minutes here it would have busted because the Rootkit is poorly programmed. So this is how it is when you detect it. The files, the processes, and everything else is the same. It's what we were doing with the cores and the binds. The other demo I wanted to show is what I've said earlier on, to call the high-level API. And it's cool because it's incredibly fast. So you call this, it makes a number of calls, and that's it. And it tells you the PID, because it's just calling and see what happens. So you get the PIDs of the hidden processes, and I haven't, for this concept demonstration, I haven't done anything else. Then you could look at the command lines, etc. So if you do ls, if you try to list this directory, you cannot do it, you cannot open it. And here you say, the guy is silly, because I am going to hide this, but if you write something else as I want. So I pick this from here. So this would be the use for this type of tool. Then we want to integrate everything in the unhide from Linux, because it's also very fast. I don't know, you want to add anything else? Just that you promised to have it before the rooted, but it's done. I just have to integrate it. So things that we want to include: the confirmation of compilation with static. I've said earlier on that want to compile something static, it won't let you, but try to compile something static and then parse that SSL to see whether it is static or not. So you're doing something that it doesn't compile static, then I detect what you don't want me to do. So what's always very useful is to have different sources for comparison. Something else that I had a bit of an idea that was sort of working was to say, I take a program that emulates itself, the call to the system, and then I introduce in the file all the instructions that goes through. So I do list files, and then I put in the file everything, and I do one dynamic and one static. And if the instructions that I go through from a static to a dynamic program are not the same, it means somebody is intercepting something at some point. And because the intercepting it's usually at the beginning, well, that's another way. We have to start at this because we would have to introduce the emulator or something that perhaps is a bit heavy, but so some countermeasures. Yes, I'm going to run because we have little time left. So what can we do to try to avoid this? If there's something we can do, Regarding rootkits based on binaries, it's very simple because almost all modern distributions have installation facilities such as RPM and DPKG in the case of Denia that take to the sum of the comprehension sum of binaries. So directly with the RPM minus VA or with devsums minus A, you can see what has been changed in the system. There are other systems of this sort, tripwire, and in the case of modules in the kernel, Linux uses the secure point, I think quite appropriate. So the kernel would not load a module without the digital signature. It's not like Microsoft that you have to pay a lot of money to be allowed to sign your own programs, but with these tools that I've listed here, you can generate your own digital certificate to sign the module and do the enroll, which is rather a secure enroll. It asks for a PIN. You have to reboot the system. You cannot do an enroll of a pirate certificate without having to overcome a reboot and introduce a PIN. So it's rather safe. Regarding the execution of binaries and unsigned libraries, here we have to say that Windows is way ahead compared to Linux. You know that in Windows there is a cryptographic integrity of binaries, libraries, etc., and you can even define different scenarios and different priorities, whether the binary is signed or not. And with Linux, that's not the case. A project was launched to try it, but it died, and since 2009 they've stopped implementing it. And later on, it is true that in the Linux kernel, an architecture, a ciphering architecture or cryptography in the kernel that in theory should offer this function. A library where you can define whether the library, if it's not signed, cannot be uploaded, and if you have a binary without a digital signature, is not executed in the system. But the problem is that it is quite complex to use. I took the documentation of the IMA and the program of that says that, and the program about how by having less taxes you can collect more money, and that program was easier for me to understand than the other one. In terms of the process injection, what's easier is to enable the penetration of the system. You can no longer use it for good or for bad, and if you think that's too aggressive via audit, you can also set up rules to detect it. This is the internet question. I would have liked to cite the source, but I had them in my own system, and I have been unable to find it. Regarding the loading of libraries, in this case, I have a tool called API from API. It looked funny, but it doesn't look so funny anymore. But in each Linux process, there is a file called maps that corresponds to the place in the memory for this process. Where's the position for a library, for a resource? So when you do an injection with tools such as Index or one of the others, there is an alteration, and you can see that a new memory space has been created with execution permissions with the library that has been loaded. So if we add that RPM and DPKG have integrity, file integrity in the system, you search all of the libraries that have a process loaded, and then I ask RPM or DPKG if they know them. And if they do not know it, if they say this library does not belong to the system, and so then I show it to you. There is a process here which is legitimate. And there's a library that's there, and you should know why. And this is a way to detect many types of processes injections. We have no time, really. Well, the conclusions are pretty obvious. Okay, very quickly. This is done all from the attacking machine. We're going to do what Yago has said. We're going to take one process, launch it, and inject a library. It's very simple. It's called sample target. and it does print CD or sleeping, and we're going to inject a library in execution time. So we're going to inject the library here. So this is just sleeping, and when I inject the library, you add a code. What was the name? -n sample target. -n.
Vale. Perdón. Sí.
I apologize, I was trying to run so much, I got confused. You see that it says I just got loaded, and very quickly, if we go to here, we have to execute this with Python 2, and here it's looking for all the systems, and here it says in this process what this library doing here. It's a very simple way to see that there is a library being injected in this process. And now very quickly, just some conclusions. Well, basically, beyond all the rootkits that we have seen, there are some more sophisticated ones to do the BIOS, UEFI, which is quite difficult to detect in a light way because many people say, no, I'll do a forensics, but the way you prove things is to looking sort of on the live mode, which is when you are competing on equal terms with the attacker. And if you develop this anti-rootkit code, I want to advise you that you shouldn't publish everything because it's sad, because otherwise we start with the anti. You always have to keep something up your sleeve to be able to surprise the attackers. And that's all. Thanks very much. It was a real pleasure.
No. Bueno, gracias a mi novia por aguantarme preparar las diapositivas.
So thanks for my girlfriend for putting up with me when I was getting this ready. Other questions?
Una pregunta de algo. A ver, ¿dónde? ¿Verdad? Ah, claro. ¿Vais a compartir el micro? Ah, vale. Sí. No se te oye.
No. Ahora. ¿Ahora?
Sí. ¿Puedes acercarte un poco más, por favor?
I am old school.
Sí, comparte con el de Yago. Ah, sí. Ah, sí, perfecto, muy bien.
I am old school, and because you have talked about the old techniques, I actually remember a couple of scripts to be able to install quickly a Rootkit, and one was the one you have mentioned, the shell script with the grep, but changing the execution back. You included a dash beb, and there was another script. You went in, you changed it quickly, which was with greps, but also introducing alias in the base RC, and oh yes, that's true. And I was listening to you, and I didn't know if this would detect, because binaries have been changed. You're comparing with dash bin, dash PS. so it wouldn't hide it for the user, but not for the program. I don't know. Well, it's very interesting because if you call directly the PS route and rather what it's looking for, maybe that's a good idea to introduce more features. I will introduce that. Yes, and you can detect more things with what you've just said. Thank you. Another question. Hi. I wanted to ask a question. What you've said about that sometimes it crashes, and you've said that it's the rootkit's fault. Do you have no way? Could there be false positives in that case? Do you do any check-in to check that it doesn't crash? Yes, I executed 4,000 million times. Yes, because what I'm doing is my code is executed 4,000 million times or 4 billion times. So I tested with Rootkit and without, and if there is a lead, you see that because I'm checking on the CPU and the RAM. So if it happens in 2 minutes, and it crashes in 2 minutes, I realize that it's not my fault. But because we have to execute the same bit of code 4 billion times, then, and if I see, I'm watching it, but it's quite manual, something that we keep doing. I don't know if that's good enough for you, or do you have a better suggestion? Well, I know that you can do demos to see if you get out of the status you should be in. Your company sells code audits? I'm just asking. No, but it's very good. Just to know. But code is public, so anybody can see or collaborate or analyze. Questions, suggestions? Come on. Take a stand. Okay, thanks a lot.